Hello guys, so today I'll be solving this problem. This is coupon code validator. Okay, so the problem states that we have been given three arrays of length n that describe the properties of n coupons. So every coupon has a code. Okay, so we have a code. Okay, and this is for every coupon. Okay, so we have a code, we have a business line. Okay, let's call it BL, and we have whether that coupon is active or not. Okay, so is active. Okay, cool. So these are the definition of a coupon. Then yeah, so code I is a string representing the coupon identifier, so the ID of the coupon. Then business line, a string denoting the businesses category of the coupon. Then and yeah, is active, whether the coupon is active. Okay, then a coupon is considered valid if all of the following conditions hold. Okay, so code of I is non-empty and consists of only of alphanumeric characters. Okay, and underscores are also allowed. Okay, then business line check is that for an ith coupon, if the business line falls under these categories, then only this is valid. Then the last thing is that the coupon should be active. Okay, cool. And then the question asks us to return an array of codes of all valid coupons. Okay, sorted first by the business line in the order. Okay, so electronic coupons should come first, grocery coupons should come first. Okay, then pharmacy, restaurant. Then and yeah, if two coupons have their business of the same thing. Okay, like if I have two coupons, let's say related to electronics, then I need to sort them in lexicographical order. Okay, cool. So it's a basic implementation problem, so we just need to do what the question is asking. Okay, so what we need to do is, so we have to iterate over all the codes that are given, or the coupons. Okay, and for that we have some checks. Okay, so first check is like the coupon ID. Okay, the coupon ID, it should be alphanumeric. Okay, alphanumeric plus underscores are allowed. Okay, then the second check is whether they are whether the business line in which the coupon belongs to, okay, that is falling under this electronic plus grocery categories. Maybe I can copy this. Yeah, okay, so that should fall under this category. Okay, then the third check is yeah, the coupon should be active. Okay, so is active of this coupon should be true. Okay, yeah, and after this check there is this sorting logic. Okay, first if let's say for two coupons, if the businesses are same. Okay, businesses are same, then we have to sort them by lexicographical order. Lexicographical order. Otherwise, if the businesses are different, then we have to sort them in this order. Okay, order given. Cool. So simple implementation. I think I will just start coding, and then you guys will have a understanding how to do it. Okay, so yeah, because there's nothing much to do, is we just need to do what the question is asking. Okay, so first of all, what I will do is I will first create a my answer array. Okay, let's call it vector of string of ans. Okay, and then I will have a hash map. Okay, so that I can capture this priority of this ordering. Okay, so let's create an unordered map. String int. Okay, I will say maybe order, and then I will say maybe I will just create this, and I'll just copy this. Okay, then I can say something like this for let oh no for business in this categories. Okay, so order of B, it should be incrementing, right? So I'll do let's do it some O. Okay, and here I will increment O. Let's call it O as starting with 0. Okay, and as we keep going, I will just simply increment it. Okay, So yeah, so electronics will get value of 0, grocery will get value of 1, pharmacy will be 2, and restaurant will be 3. Okay, cool. So my priority and my answer arrays are created. Then I will create one more array to store the indices of the valid coupons. Okay, so let's call it valid codes, and let's make this code thing to codes. Okay, so here I will store the indices. Why I'm storing the indices first? Because first I will store the indices, then uh, I will sort those indices of the code based on this requirement. Okay, then I will update my answer array. Okay, cool. So I'll show you how we can do it. Okay, so first I will iterate over all the coupons, but yeah, I need the total number of coupons. So n equal to codes dot size. Okay, then I will iterate for I greater than 0, I less than n, I plus plus. Okay, cool. So I will get my first coupon. So string code equal to codes of I. Okay, now I will check. Now I will create a flag. Okay, that will perform all this check. Okay, so I will initialize that flag as all okay. I will start with code size should be more than 0, because yeah, my codes should be non-empty. Okay, then the second check is character by character. We need to check whether all of them are like alphanumeric, or they contain underscores. Cool. So I will iterate over all the characters here. So C in code. Okay, then I'll say all okay equal to yeah, so this will be lengthy. I can say all okay and of. Okay, so if my current character is more than equal to a, okay, small case, and less than equal to, let's say, z. Okay, and then I will need this thing. Okay, cool. Okay, this is there. Then I'll say in capital cases also, C this uppercase Z. Okay, or then there is a numeric check. If C belongs to this, to C belongs to, okay, if it is 0 to 9, or C is actually a underscore. Okay, then yeah, it's all valid. So I'll simply check that. Now I can break out of this loop. I can simply check if for any character this all okay becomes not all okay, then I will simply break out of this loop. Okay, cool. Then let's say all characters are fine. Then I will check whether the business this coupon belong to, whether that is in my order. Okay, like my order contain electronic, grocery, pharmacy, and restaurant. So I will check that. Okay, so I'll say all okay equal to all okay ANDed with my finder, or yeah, order. If order dot count. Okay, so, or I can say if order of this business line, whatever this coupon belongs to, okay, business line of this ith coupon, okay, if that is more than 0, okay, maybe I can start this with 1. So this will contain 1, 2, 3, 4. Okay, so any business line which has a frequency of like value of 0, then that means it does not belong to my order. Okay, so yeah, so order check done. Okay, then I will final check is this active check, whether that coupon is active or not. Okay, ANDed with yeah, ANDed with is active of I. Okay, if my coupon is active, then I will simply say all okay, and I will push this index of this coupon, okay, which I will later use to short them. Valid codes dot push back I. Cool. Now I need to short them. Okay, so I'll say valid codes begin valid codes end. Okay, I will write my lambda here. Okay, or let's call it auto A, auto B. Okay, and yeah, cool. So I'll write the sorting logic, but after the sorting of this valid code, I will simply update my answer array. So for id in valid codes, okay, I will do answer dot pushback of codes of id. Okay, and I will return answer. Have I written that? Okay, I haven't. Cool. Now there's a sorting logic. So if my eighth coupon, okay, if the eighth coupon business line, okay, is equal to the business line of bth coupon, then I will return lexicographical sorting. Okay, so code of A should be less than code of B. Okay, otherwise if it is not equal, then I will return whatever I have set the priority here. Okay, so that will be finder of business line of A. It should be less than find the priority, or so yeah, this is the order, yeah, the order of business line of B. Okay, cool. So yeah, I'm using this order to sort the businesses of for my coupons. Okay, but if the businesses are same, then I'm doing the lexicographical sorting or the lexicographical ordering of the coupons. Cool. So after this, I'm iterating over all the codes or the indices of the valid coupons, and now these are sorted. Okay, and I'm updating my answer. So let's run this. Cool. Something didn't work. Codes. Yeah, this will be codes. Yeah, it's changed it to codes here. Yep. Codes. Yeah, anything else? I think that's all. All test case passed. Now let's submit. Voila, it got accepted. So yeah, that's the logic. And if you look at the time complexity, so I'm just creating so let's look at the time complexity. Okay, so the creation of this, it will be constant because there are only 4 values I'm inserting. Okay, so there will be no hash collisions because yeah, there are only 4 values. Okay, then yeah, I'm iterating over all the coupons. Okay, and I'm doing a character level check. Okay, so I'll say big O of the number of codes I have been given. Okay, times, so the worst case scenario will be all of the codes are of the same length. Okay, and they are of maximum. Okay, so I'll say big O of maximum, sorry, times the length of the longest coupon. Okay, and am I doing anything else? So this is also checking. So this is a big constant time operation. This is also constant time, and pushbacks, yeah, these are constant time. So yeah, this for loop time complexity is number of codes times the length of longest coupon. Okay, then I'm doing this sorting. Okay, now whatever valid indices I have collected, those I'm sorting. So I can say, so at max, so what's the worst case scenario? All codes are valid. Okay, so in that case I can say it's a big O of, so it's a n log n sorting algorithm, right? So it's like number of codes times log of number of codes. Okay, so that's the time complexity for the sorting. And then there is this um, answer updation, which is again big O of number of codes. Okay, because at max valid code can be all the codes itself. So yeah, so yeah, this is my overall time complexity. So at asymptotic time, I think this too will be governing my time complexity. So yeah, cool. Then as per space complexity wise, so I'm just creating this auxiliary space which is like of 4 sides. Okay, so yeah, so there is a big O of 4 involved. Okay, and yeah, there is this valid codes, which is I'm storing the indices of the codes, and at max I can store all the code indices. So there is big O of number of codes. Okay, so at worst case time complexity, this will override this value, so this will be big O of number of codes. Cool, so that's the space and time complexity. Now let's quickly do it for Golang. Phew. Oh, I have already done it. Maybe I can show you guys. So what I have done is, yeah, so yeah, similar to what I did in C++. Okay, so there is this finder. I'm creating this hash map, so similar to what I created in C++. Okay, I created this unordered map, so this same thing is resembling here. Okay, then I'm iterating over all the codes. Okay, then I'm doing the same length check that I did here. Okay, I'm doing the same thing. Okay, then character by character I'm checking. So in Go we have to use rune. Okay, so yeah, I'm just doing the same stuff what I have written here, but in Go fashion. Okay, then I'm checking whether that business line for that ith coupon exists in my order. Okay, I have used finder, but yeah, that's the order, so I can change this to maybe order. Okay, so yeah, that's my business line. If it exists in my order array or my order map, then everything is fine. But if it does not, I'm updating my all okay to false. Okay, then finally I'm doing this active check. Okay, now if it is good, okay, everything, then I'm updating my valid code. Okay, then yeah, this is the sorting logic that I have written in Golang. Okay, the same lambda function that I have written in C++. Okay, its exact replica is this thing. Okay, so yeah, and finally, and yeah, I'm iterating over all the valid codes and I'm updating my answer. So yeah, that's the idea. Cool. So for Golang, let's do check it for all test cases. Okay, I think good. Now let's submit. Cool. Everything passed. Now let's finally check for Rust. Yeah, so for Rust also I have already updated the code. Okay, so similar stuff. Okay, so I have created this hash map. Okay, now I'm inserting all this strings there. Okay, like all the orders that have been given. Okay, similar stuff that I did in C++ and Golang. Here also I'm doing the same stuff. Okay, then there is this valid code. Okay, and yeah, I'm iterating over all the code IDs. Okay, but yeah, in Rust there is this string like collecting the character at the ith index, that that is not optimal. Okay, because it will iterate over all the character level by like index by index. Okay, so instead it's best to first convert them into bytes, because bytes you can use like array kind of indexing. So yeah, I'm using this bytes. Then yeah, again I'm doing whether the code length is more than 0. Then I'm checking for all the characters whether those are all alphanumeric and underscore. Okay, if something is wrong, I'm breaking out of the loop. Okay, then yeah, then I'm checking whether my order, okay, I have used finder, let's change it to order. Okay, so whether my order contains the business line ID of that coupon. If it is, okay, then do the last active check. And yeah, after that push it to the push the ith or the index of the coupon in your valid code. Okay, then do the sorting. Okay, first if the business lines are same, then sort the coupon by their IDs in lexicographical order. If the business IDs are differing, okay, then sort them by their priority. Okay, which is this 0 1 2 3 value. Cool. Now once that is done, then you just simply update the answer. Cool. So here noticeable things are yeah, I'm collecting this value, I'm dereferencing it, then this gets an option. Okay, then I'm unwrapping it because I know the value will always exist, so it will not panic. Okay, so I'm using unwrapping here. Okay, then here, okay, codes of I, so I need to use clone here because if I simply push codes of I, then it will be moving that value from the codes. Okay, and codes is not mutable here, like not related to mutable, but yeah, I'll be moving that value, which will give a panic. Okay, cool. Then I'm returning answer here. So yeah, let's run it for all test cases. Now let's submit. It passed for all test cases, and voila, it got accepted with 0 ms. So yeah, that's why never trust this star. Okay, never trust this thing in LeetCode. Okay, you never know when it will be 0 or maybe some large value. So yeah, that's the idea, and this is the time complexity. So nothing much to do, just simply do what the question is asking, and you are good to go. Okay, so yeah, I hope you learned something new. If you like this video and the solution and the code writings, okay, please do subscribe to the channel, and you can put a comment in the video if you have some doubts. I'll be happy to answer your question. But yeah, that's the logic, and here's the code. All 3 languages done. Cool. Just stay tuned to watch more videos. Thank you.